for instance, we will look at what exactly were the original generative models, why are we here, why are we talking about AI agents, and how can we build an AI agent with a development kit, like for instance, the agent development kit that was released a few days ago from Google. I'm not sure how many of you have heard about this, but this is one interesting, also a development, so to say. There is also another framework that I will be talking about, which is called Crew AI, which is also another framework for developing agents. In this talk, the goal is to make sure that you understand the basic concepts and you can approach any agent development with these concepts. So the goal is to show what it means to develop an agent and then use these agents for any of your use cases. But before we jump into any of these, the talk about what is an agent and so on, the first point would be what exactly, like, where were we, what were we doing before, and why are we talking about agents, right? So we were speaking about generative AI, and now why are we speaking about agents? So typically, what happened was the main question that we were always talking about was LLMs, or generative AI is always a single, like a one-way street. So where you ask a question and the model generally responds with an answer. And the problem, what happens here is that you would be basically, this is always a bit restrictive. And what happens is that there would be no external knowledge. So which means that the model is trained until a given date. And then after the point, you will not basically have any of the ways to update this model. So it's basically an approach where you would have something like a pre-trained model, and then the model basically gives you a data cutoff date, which means that it understands information until that particular date on which it was trained, but it would not have any external real-time knowledge. So this is where, so this was one of the shortcomings. And then what we did was we have something called retrieval augmented generation. What this means is typically taking new knowledge and then trying to incorporate this knowledge into the model as an additional on the top. And then we were trying to get this information, and then you say, what is a pixel tablet? And then you basically, it's a query. And then typically you will have embeddings that will basically represent this query that you have. And it will also have an external knowledge base, which means that it has like tokenized versions of embeddings and so on, a large vector, which is then used to ask this question and then try to figure out the closest answer or the closest possible chunk and try to come up with an answer for this particular query that you're asking. So because of this external knowledge, what happens is it's not necessarily the example that we showed here. It's not, there is no shortcoming of, the lack of new information is not there. We can avoid it, and then we can feed in additional new information, context specific to the target, the use case in mind. Which means that when we now ask what is a pixel tablet, we can then get an answer. It was designed by Google and contains a T2 cheat and so on and so forth, which is fed from the external knowledge base. So this is nice, but the problem is that what happens is we want to do a bit more, which means that we want to have additional reasoning, we want to have additional data, we want the model, the model itself to do a bit more reasoning, and we want the model to have access to tools, which means that the existing paradigm that we have is not sufficient with what we actually want to achieve. And this is where we have AI agents. What this means is that agents have the capability to not just answer questions, and also basically understand when they have to ask for a tool, but also you can incorporate parts of your algorithms within the tool to make sure that they interact with one another. So an agent effectively allows you to generate a process by which you can actually give a task and output, and basically the agent tries to collaborate with other agents together with tools to come up with an answer for the task that you actually provided as a goal. And so this actually makes it very easy to actually use LLMs. And so all along we were saying, okay, we're just going to ask questions. You're going to give me an answer. So you go to AI Studio, for instance, on Google AI Studio, and then you ask a question. It was always giving you an answer. This was always a very sort of like, it was not really useful in a real world scenario. But then we started to realize what an agent can do, and this is exactly what we will see. So here you provide the model with the capability with tools, and what this can then do is it can, for instance, go into a vector database. It can ask questions. It can actually ask search within Wikipedia. It can do Google search as well. What this allows us to do is it makes it easier for us to actually invoke the necessary tools that are needed, and then in order to get the answer that we are looking for. So this actually made it even more powerful, and this is exactly why we are looking at what we want to achieve with an agent. An agent, in that definition, is an application that uses a combination of generative model capabilities, tools to connect the external world, and a high-level reasoning in order to achieve this goal or the state that we wanted to achieve. So this is what I wanted to do, basically provide. So we have not just the model. So this is where we started, but we also provide tools. What this allows us to do is it also has the ability to reason, and also, of course, deploy all of this in the end into, for instance, like a Vertex AI or any of the cloud providers. So this is the way in which we can actually start to think about what an AI agent is, and how to actually, why are we even talking about such cases. But the main challenges that we have today with building these agents is that when we work with such agents, the main problem is we have very limited control and customization. So basically, when we will look at two different frameworks. We will look at the agent development kit, which is provided by Google now, and another kit, which is another framework called Crew AI, which is generally available outside as well. And we will see what are also the contrast and compare what these both of these provide. But in general, the main challenge is the control and the customization is difficult. And what happens is that we also have timelines. So the timelines are long when moving from, for instance, prototype to production. This is a case especially with agents. If you develop agentic frameworks, then the challenge is it would work well in, for instance, development mode. But then the minute you think about moving into production, you're going to have several limitations in terms of like scalability, in terms of like how well the model actually can be deployed, and so on and so forth. And the third point is also about maintaining this code. So for instance, because these frameworks are built with the open source community in mind, and also to come up with quick development prototypes, more often maintenance is very difficult. So you will find that over time, maintaining, keeping it modular and maintaining all of the layers is going to be challenging. And finally, it's also difficult to implement in cases of like, if you're especially working in an enterprise, sort of like a setup, then such agentic frameworks, it's very difficult to implement and also, use them with such requirements. So this is exactly where Google then provided this development kit, and this is also something that we will look right now. So here, this is very fresh off the press, so to say. So we have an agent development kit, which was developed. It was released about 3 or 4 days ago, and we have very nice capabilities within this framework that we can leverage to actually come up with beautiful applications that can actually solve a lot of problems for us. So in general, I would suggest even with LLMs or any of these scenarios to basically think about the business problem first. And in general, then you will be able to think about what you need to build, and then you can build it. So in this particular scenario here, you see basically we write an agent. So typically an agent will have some instruction. The agent will have some tools that you can actually provide to the agent, some callbacks, so that before the agent executes or after the agent executes, or how was the agent actually executed. So for instance, is it a sequential execution? Is it a hierarchical execution, and so on? So all these definitions actually come within the agent definition. And what you can also do is you can, for instance, incorporate external tools which also allows you to have some really interesting ways to interact with the external world or with APIs that are available outside. So this is a very useful kit, I would say, especially in terms of if you're working with a deployment on an enterprise-ready software. Then the ODB, the ADK, would actually allows you to make it easier for you to develop and deploy the sample framework that I would also show you in a couple of minutes is basically something like a question where I ask what's the weather in NYC, New York, for instance, and then the weather where the agent has several other agents within the framework itself. But what it will do is it will process the query, it will call the get weather agent or the tool, and then it will try to then subsequently answer the question based on what the question was asked. So this actually makes it easier. So especially, of course, this is a very simple scenario that I actually used here to make it easier for you to see what is the scenario here. But we will also see a pretty complex scenario where we will actually do marketing competitor analysis. So what we can also leverage is such tools, but at the fundamental level, what we are doing is we are providing a query, and then the query is then interpreted by the agent itself to understand and process the tool that is required, and then the agent calls the tool that is required for that particular query, and then gets the answer so that the user can then subsequently use this information for that particular query. So a very simple definition here, but that I will also show you in a minute on my VS Code, is basically where the definition is rather straightforward. You would see there is an agent with a name. So here you can give whatever name, and then you need to also provide a model. And this is where the switch comes, especially when you're thinking about how do I use it locally, right? So in this particular case, I'm going to use, to start with, I will use Gemini 2.0 Flash. You can go to AI Studio and then you can get an API key. It's very simple to set up, and then you just need to create an environment variable, a .env file within your code, and then this agent will work out of the box. But if you say I don't want to use an API, I want to basically use everything locally. I want to use Gemma, right? So the goal is also to say how do I integrate Gemma within this scenario. Then I will also show you how we can do that. There is a different setup with Crew AI that I will share, that we can also see how to do the same, accomplish the same task in order to get is that the agent can actually answer these questions. Why are we giving an instruction? We don't want the agent to do anything else apart from what the agent is actually supposed to do. And the description basically provides the agent with the parameters on what it has to accomplish. And the tools, we give it two method calls, which will, for instance, ask an API call, or it will basically ask the system for a given location, what is the time, and so on. So as you see here, the example that I provided here has a very simple sort of like a setup. At least, of course, it looks quite simple, but we need to then also see how exactly this works. So for instance, here you will see there's this the framework actually allows you to not just set up, but it also says where was the request sent, and who responded to that, and so on. So you will see, once you make it a bit more complicated, once you have several tools for the agent to work with, and if you have several agents to work with, then this entire graph looks quite different. But in this particular scenario, you will see it's actually quite nice. I will also show you a working example of how exactly this looks. But this is, as you see here, there is actually a question. So if you ask what is the current time in New York City, then it's basically going to make a request, and then it's going to call the, if you work with LLMs, this is also called the function calling. But then the point here is to show that it can actually call a tool, and as an agent, it has these tools available, and then it can accomplish a task. So this is why, if you're wondering, hey, what's the difference between this and function calling? In a function calling scenario, it's a bit different. The framework or the agent, there is no agent which understands what it has to do, and then you say when this has to be called. In this particular scenario, the agent knows which tool to call based on the question that you're asking. So there are subtle variations which are useful in accomplishing the task. So this is why in an agentic framework, you basically work with the end descriptions and the end task that you want as a goal, and then you build an agent or a set of agents with a given set of tools that each of these agents can use and then interact with one another in order to build a final result. So this is a very simple example. I can also show you how exactly this looks. So let me open my VS Code. So here you go. So this is one example. Let me first, in order to make it easier, let's go to the ADK example. So the agent development kit. Let's look at what exactly, maybe this might be a bit too small. I can make it a bit larger. So here you see basically what it is as the definitions I told you. So there are two method calls. So you have the get current time, get weather, not important at the moment. We know that it always takes in a city as a string, and then it provides either the weather of that particular city or the time in that particular city. What is more interesting is, for instance, if you want to have a local LLM, so then you get into interesting scenarios. Right now, there is support for Gemma 2. There is still no support for Gemma 3. And this is why we will switch to Crew AI, which actually provides pretty cool support for Gemma 3 as well as any of the other models available from Olama. But I don't want. Let's talk about the agent first. So here you will see this was the previous definition that I shared here. What you can also do, you can also provide additional information. So for instance, I can actually expand it to other tools. So as I said here, the get weather and the get current time are local definitions, which means that I wrote the method and I asked the model, I give the tool to the model and then ask the model to use this particular tool whenever it sees fit. But what I can also do is I can provide Google search as a grounding mechanism. So irrespective of the question, I can always make a Google search and then provide this as an answer. So we can see how this actually looks. So for instance, in this particular scenario, this is rather easy. So let's not worry about this. Let me comment this out. Let me go to this one. I think this might be a bit more interesting. What we will do here, we will use the Gemini 2.0 framework. But again, the nice thing with Agent Development Kit is it offers you with the ability to also run all of this within a local framework setup. So what you can then do is you can actually go to localhost, and then you can actually look at the tool. Here you'll see the multi-agent tool is the tool that I created. And you can also see the state. So before I ask a question, what is the time in, for instance, Islamabad? So this could be an interesting search. Now you will see basically it actually provided the answer already, pretty cool. And if you look into how it actually did that, so there is a state, there is also a session. I can look into the agent. Here you will see basically what it's actually doing. It's doing a call to a Google search, and then what it's getting this information from is timeanddate.com. It's also doing a clock.zone, and then what you can see is it has a confidence score. And basically it says, okay, the current time in Islamabad, and then basically it says this. So the utility of this particular scenario is actually quite nice. So you basically, if you ask such a question, so what is the time, so what is the weather, could also work. The weather in Seattle. So this would then make a different query, but what this will have here, we don't have those two tools, the get weather and the get time, but rather we have a single tool which basically makes the same query, but on Google. So basically here you will see the weather in Seattle is nice, and so basically it provides a lot more context around this question, which might not be necessary. And this is where we can then decide whether this is useful or not. So here you see this is a basic search agent, and then it just does a Google search. I can also see the request response cycle. There is a request here, and what also was the response cycle. You can also see the URLs that were searched, and you can also see, there is also different parts, different chunks that it used to actually come up with the answer. So all of this is actually really useful with the ADK, with the Agent Development Kit. This actually makes it a lot more sort of debuggable. You can see why the agent behaved in a manner. Probably if you have questions on why this didn't work, then you can go into the state, you can go into the session, and then you can see how this event, the request and the response cycle was, and then you can start doing all of that. But as you see here, so this is actually very useful. Of course, the goal for us is to basically use or we want to develop a local agent. And for that, what I will do is let me first start talking. I'm not sure how many of you have used Olama, but the goal with Olama is more like a repository of large language models that are available. And the minute you have Olama on your laptop or on your server, what happens is it actually creates a local server, and it hosts the model on your server as well. And then what you can do is you can see the list of available models that are there. So in this particular example, what I'm going to do is let me kill this, and then I just close the server. What I can do is I can say Olama list. And here, for example, I have Gemma 2 billion. I also have Llama 3.1, 3.2, all of them. So we can use any of this for our particular scenario. And what I wanted to show you was basically how can I use Gemma 3, right? So the question is, I want to use Gemma 3 and I want to develop something with Gemma. So this is the interesting part. So what we are going to do in the first particular case is we will use Gemini. So the first example is where I want to create a documentation agent, and here I will use Crew AI. So the setup is very similar in terms of like what the agent will do. The agent has, as I said before, a particular goal in mind. It has some instructions. So you will see the agent will have a role, an agent will have a goal, a backstory. And in this particular scenario, I will also provide it an LLM, which says which LLM I'm going to actually use. And in the case of Crew AI, what I can do is I can feed the same Gemini key, but I get it from the environment variable, which is set in this environment. So typically, if you go to the sample, you will have this, you will just set it up like this. It's just a key that you get from AI Studio. You can generate your own key. If you go to AI Studio, you can then go to API, and then you can generate your own keys there. The goal here is then we say this is one agent, and this is another agent. And we provide this a particular, so the agent has a task, which means that for any task, so the agent is provided the task is actually connected with an agent, which means that in this particular scenario, the agent task has the agent as the info agent, which is this one. And in this particular scenario, I am asking it to say, give me a step-by-step guide to write a blog post, blog on AI agents. Let's make it AI agents. And basically, I also wanted to have some expected output and so on and so forth. I would also wanted to provide all the output in an output file. And what you see here is it's rather straightforward. So if I basically say main Gemini, you can then, of course, run all of this. So you will see that basically it's all verbose outputs. It's going to basically, right now it's pinging Gemini. What it's going to do is here you see basically the crew has started. What it's also saying is there is a task for that particular crew. Let's look at this later on. Okay, that's a pretty detailed guide. Sorry about the scrolling. So it basically says, okay, let me scroll it even further. So here it's basically saying, yeah, here it is. It's there is a task that it's actually saying, okay, you've given me a target to write a blog on AI agents. And the agent that it thinks that will help is here the documentation agent, and it's starting that particular task. And it's going through step by step. It will basically call an LLM here. In this particular, the LLM is the Gemini API, and it gets the answer. So here it's saying the documentation agent is what I'm using, and the final answer, this is the answer. So of course, it's very difficult to look at the answer like this. So what we can do is, of course, we can actually look at the answer in preview as a markdown, because I said there's also the task for the agent. It can store the results in an MD file, in a markdown format. And you'll see here, it's actually done a pretty decent job. Of course, with any LLM, go through the information, try to do additional, you need to fix something, all of that. In this particular scenario, I'm not doing that because the goal is just to get a quick start on a blog, and I want to get some ideas. I want to get some thoughts, like a brainstorming session. So this is a very simple example. What we can do the same thing. So now the question is, hey, I want to do it with Gemma, right? So you will see, so here you with the crew. So first of all, I say the agents that are available and the tasks that are available for that particular agent, and I just say verbose to true so that I can see the results on the command line. And finally, it will provide the results. So yeah, nothing fancy here. What we are going to do next is we will use Olama. Let me clear this and let's go to the Olama part. So again, as I said before, in the Olama setting, you will have to do slightly a bit different. The definitions for the LLM and the Olama part will pretty much remain the same. Let me put this side by side so that you can also see how exactly this looks like. So this is the Olama part, and this is the Gemini part. So you will see on top, basically from here, you'll see pretty much it's going to remain the same, except that here on the left, you have the Gemini model. On the right, you have the Olama model. As you see here, I have in the LLM setup, I basically say, please use the Olama Gemma 3. I can also do this now. I can say, let's comment this out, and then I can actually uncomment this one, and now run this one. So let's quickly run this and let it run in the background while I explain what's happening. So what is happening on the right now, as you see here, everything else is the same. So you have a step by step. You basically, it's basically going to do the same thing. It's just the same documentation, and you will see the information it's actually generating. Everything else remains the same. It's just that we've switched the models between, so with the Gemini part, and then we switched it to the Olama part, and effectively Olama, which is running on top here, is going to then do the heavy lifting. Now behind the scenes, there seems to be, okay, no Gemma 3 found. Let's do it with Gemma. I think it's 2 now. Right now I think I deleted Gemma 3. So let's do Gemma 2b. So let's see what is the model available here. Olama list. And yeah, so I think this here it's Gemma 2b. In this particular scenario, irrespective of whether it's Gemma 2b or actually Gemma 3, doesn't matter. I can also do a Gemma 3, but before you do Gemma 3, you need to just do an Olama pull. That's the only small thing. But besides that, you will also set this base URL, which means that why? Because Olama is running on a URL on a port like this. So you will simply set this up like this, and then you will call the Olama, and pretty much from there, it's going to take a slightly a bit more time, because now you have to remember that you're running a local model. Everything is running locally, and it's going to interpret, and it's actually calling all of this information. It's actually done. Interestingly, it took 30 seconds. Not bad, I would say, for actually generating this information. Let's go back and see what it actually generated. So let's look at this one. So, okay, it's actually, I would say it has done a pretty decent job. Let's close these two, and then maybe we can look at this like this. All right. So yeah, as you see here, this is also pretty. Is it the same, or I think this might be the same? Did I save this to output.md? Yeah, I think I saved it to output.md. Interestingly, did I run Olama? Yeah, I think I ran the Olama, so that is not a problem. So everything is fine. So here, maybe I didn't refresh this one, because I think it's opening still the other one. Anyway, so I think as you see here, the answer is a slightly bit different here. So here we have, so what the model does, it actually provides a step-by-step instruction on how to write the blog, on what exactly is an agent and what it can actually do, and so on. So as you see here, again, the important point is to basically think about the problem that you have, and then try to set up the crew, and basically also the tools that you provide to the crew. The interesting thing with Crew AI is that you have several tools available. Here you have just one small tool, which is basically, in fact, I did not even give a tool. We can actually go into, as I said before, we are going to actually look into a pretty complex task. So in this particular case, let's close everything else. and then look at this through. So here I'm using Llama 3.2. And I will be actually, so the definition of this particular scenario is a bit different. As you see here, I'm actually creating two agents. One is an analyst agent and one is a research agent. And basically, I have for each of these agents, I'm giving two different tasks. One is to basically create a reporting analyst, and the other one is to say a task analyst. So basically, the research agent has a research task, and the analyst agent has an analyst task. What the research agent, the job of the research agent is to basically, as you see here, it actually goes to the web and then scrapes information. So what it does is there are two different tools given to it. And so based on the task that you have, what it will do is it will actually go to the internet and then it will try to search for this and then bring you information back. So if you look into the main file, so here, for instance, I can actually ask questions about, say, what happens. Let's talk about Microsoft. And then we can, in the meanwhile, we can make it actually run through this, and we can also see what the results that it actually creates. But the goal here is basically that we are actually creating an Olama crew, and then you can actually then set up all of this information within the Olama crew and run this. In the meanwhile, while this is actually running, are there any questions or any comments, anything that you have you want to share while I actually set this up, while I actually call this? So what's happening right now is basically it's trying to call the agent, as you see here. It's trying to do a Microsoft researcher. So there are two different agents. We can actually look at why this actually did this. It'll actually go to the web and it'll actually try to collate all of this information. And what it's doing here, it's using Olama as the large language model, which means that it is actually using Llama 3.2, and it's trying to do all of these calls. And here it's a slightly complex setup here. There are two agents working with each other. So the first agent has to finish its task and then come up with the answer. And the second agent will basically, the first agent goes to the internet, does a search, and then also goes to each of these links. And then it actually tries to come up with an answer. You will see here the question that it actually goes. And then it, as you see here, it's actually doing Microsoft search. And then it's saying, okay, I did a search, but something didn't go well. And then it actually tries to use something else. And then you'll see basically all of this, it does all of this by itself. It will try to switch something else and so on. So the goal here is it's trying to use DuckDuckGo as a search, but it looks like it did not go well. And I think, it'll hopefully, it's trying this again. And it's trying to think. So as you see here, it's having a thought and a reaction and an action and an observation. So all of this is also documented here. And then you will see, your final answer must be great, complete as possible, and so on. And that seems to be a tool error. For some reason, the internet search does not seem to be okay. So the Serper API key seems to have failed here. It could be because of something else. It could be because I basically remove the Serper API key. But anyway, so it's trying multiple times and then it's going to fail all the time. So never mind. But the point I'm trying to make is that you can actually fix all of these agents, and then you can have these agents with different tools, and then you can make these tools interact with the agent, and the agents interact with one another. So the goal or the use, the utility in this particular scenario is you can have these complex setups. And by the way, this code base is completely available on GitHub. So in case you want to actually try this out yourself, feel free to go to GitHub. I can share the link later on. All of this is documented there. It's just that I think I have to update my Serper API key, which I was using so far for different workshops. What I will do is I can also update this. But in any case, in your case, you can simply get a new Serper API key, and then it should work perfectly fine. In this particular scenario, it's just going to kill itself. So let's not make it go further. But the point I'm trying to say is the goal would be that we actually make all of this information. We actually have all of this available, and then we can make this. For instance, I have some results here. So I actually did some research, a report on Oatly. Oatly is a company that actually manufactures plant-based milk or plant-based milk market and oat-based milk market. And basically, it did a pretty good job. So it actually provides an executive summary, it provides a market overview, it provides a competitive landscape, and so on. All of this is documented on GitHub. Feel free to try that out yourself, and then see if you have any questions or if you have any points that you think is not working from the GitHub link. Let me know. I can also, we can work on that together. But in this particular scenario, as you see here, it actually does a pretty good job in trying to actually understand the market scenarios for Oatly, and then it actually comes back with recommendations. So, for instance, what should Oatly do in terms of like offering the change in consumer preferences, new channels for distribution, continuing investment in sustainability initiatives, and so on. So all of this is based on all the news articles, what it read through the financial reports of Oatly. And basically, this is, again, what's important here is how you create an agent and how you use the tools and so on. And in this particular case, we are using three different tools. The internet search tool, the internet scrape tool, which actually scrapes the information from the website, and then it actually generates all of this report using all of this information. So here is the second analyst, which takes this information from the first researcher and then puts it into a format that's useful for us to read through. So just like this markdown. And so, yeah, so this is all of this is running locally. So as you see here, so you can actually go to Olama logs, and on Olama logs, you can actually see all the calls that are actually done. And here, everything is local. So as you see here, it's a local host, which is actually hosted on 11.4.34 for Olama. And yeah, so this is basically a very simple, of course, it's a slightly a bit more complicated example. So what I would suggest is first try to do something with simple agents. So try to create simple agents with Gemini first, or any of the openly available large language model providers. Then try to use it with Olama. Then the differences in actually using an LLM versus a cloud API, and also then subsequently build on top of that to build in your particular business scenario. All right, so we looked at an agent development kit. We looked at Olama as well. What I will then do is, let's go back here. So this is exactly one thing that I wanted to finally close out, is something that we are also discussing now. So we have a mesh of agents, which means that we have several agents that are interacting with one another. So which means that we also need to make sure that all of these agents can interact with one another. And this is exactly why there is this agent-to-agent protocol. Why? Because we have lots of frameworks, which means that it's very difficult for all of these agents to interact without a single standard. And it's also it's representing this agent as a tool is also going to be very difficult. So, for instance, here OpenAPI specs, or even the MCP, the model control protocol, model context protocol, is not sufficient. So basically, this is where you are basically trying to bring in a new way to also have this agent-to-agent protocol. And this is also now shared here. So we will see where if you want to deploy or build once and deploy anywhere, and versus you want to buy once and use everywhere, sort of like a scenario where you will actually have these agent-to-agent protocols. So what actually happens? Here you have an agent, so a local agent mesh, which means that in an agent-to-agent protocol, you have the agents talking, for instance, with another agent through the agent-to-agent protocol. But then the agent framework itself, or the overall setup, speaks through an MCP server to basically get the tools or different other external access for all of this information. But for the agents itself, they will actually talk to one another through an agent's endpoint. So this is one interesting way of trying to come up with a general standard, but then also making it easier for agents to communicate with one another. So especially if you're a software engineer, then you will be this will be not too out of the world for you, because this is something that we already do, especially with microarchitectures and so on. So we have about 15 minutes left. So for what is an MCP, the Model Context Protocol. So here, the reason for why we need this is because we want to have external data sources and tools While in an agent-to-agent protocol, we want the agents to communicate and collaborate with one another, not just one another, also with autonomous agents without needing access to their internal resources. So basically, just like an API endpoint, but then we want them to the agent to have these abilities to do that. Typically, MCP is a protocol that connects the LLM applications for all of this information, resources, and tools. But here we have an A2A protocol, which is the agent-to-agent protocol that standardizes this collaboration between autonomous agents. So this is why you want to, think about what is an MCP, or how do you want to integrate with MCP, as well as agent-to-agent protocol. And in a scenario, where do we use it? So, for instance, in a real-world example, you will see that, for instance, in a repair shop. So, for instance, an MCP gives a mechanic access to the instruction manuals and the equipment needed to repair their vehicle. So there are several employees within the auto repair shop as well. So what MCP does is MCP provides this the mechanic an ability to actually, or the directory to talk, for which you can actually talk and then get all of this information. But what A2A does is basically it helps the mechanic talk with other part suppliers of the business. So basically, so there are two different ways or two different scenarios in which you use the MCP and you use A2A. So yeah, so I think it quickly jumped from building a simple application into standards, into already protocols, which are going to be already thinking. So you need to think about this, or by the time you build your application. So if all of this is new to you, if you've never heard, or you've heard of MCP but you never used it, or you never read about it, this is a short MCP servers where people host their applications so that other LLMs can actually access their applications and data from it. So this is a way in which you can actually make your data available to large language models for getting this information. In an A2A approach, an agent-to-agent approach is a protocol for two agents to communicate, which means that the boundaries for all of these tasks could now slowly diminish. It could actually slowly go away. So the goal is basically to solve these problems that arise from dynamic these agents interactions. So the proposal, the takeaway I would suggest is basically to think about MCP plus A2A, which means that you have a model context protocol and an agent to agent protocol, which are working in tandem together simultaneously to make it also useful if you're having multiple agents talking to one another, and also with the outside world for information. So for example, here you will say the MCP for typically if you have a database, if you have, for instance, knowledge base within, like information like documents and so on, then the MCP server comes in super handy. And then the agent to agent sort of like setup comes in handy when you have all these agents, you want all of these to remotely work with one another. So there are different ways in which you do this. It gets a bit more complicated as and when you get deeper. So don't worry, this is not something that you have to do immediately, but this might be useful, especially if you want to think about the architecture, if you want to think about how all of this works, and then in the long run, as an enterprise, sort of like a software developer, this will be useful for you to think about. So the overall vision for all of this is basically an open protocol whereby agents to interoperate with one another, and also to bridge the gap between opaque agentic systems. So this is where on one side you think about capability discovery, user experience, task completion, and agent human interaction. But on the other side, when you think about what exactly it means by opaque agents, is where agents built in various frameworks by different vendors that do not share memory or tools. So this, you're making these sort of boundaries go away with such setups, with such protocols. All right, so I think we've already covered this part. I don't want to take too much time anymore, and I think we have less than 11 minutes available. Are there any questions? I see already someone put their hands up.
Hello.
Yeah.
So first of all, how are you?
Sorry.
How are you?
Oh, I'm well, thank you.
So I have a question. I have built a tool that takes course outline as an input and generate both notes and PPT. I'm using the Gemini API.
Mhm.
Yeah, I'm using Gemini API in the backend. So question is that do you think this tool can handle multiple user efficiency? And also, what's your opinion about on its potential? How competitive or variable do you think this project considered as a generative AI project?
So that's actually so I think from what I understand, so what is your the tool that you are working with actually takes notes and then summarizes this and puts it into a
No,
presentation?
no. That take course outline and generate
Mhm.
notes and PPT.
Ah, I see. Okay, so it takes okay, interesting. So I would the challenge here. I wouldn't say this is the main problem with LLMs is that you need to check the output, and typically the information that's available within an LLM is not usually there are lots of hallucinations and so on. You need to do that check quite rigorously because you're generating course notes. I'm not sure if you're using something like a retrieval augmented generation or basically
No,
to
I
ground.
use
So
Gemini API with
yes.
different model.
Mhm. So, retrieval augmented generation has nothing to do with the API itself. So, the API itself provides you, of course, access to Google's LLMs. But the point that I'm trying to make is LLMs make hallucinations. LLMs come up with, it has a lot of issues, especially making up information, making up, all of these data which do not exist. So, what you need to be careful, I would say, is given that you're working on course notes, it's going to be difficult because your LLM would be generating information that does not exist. So, although yeah, the idea is good, I would suggest you to do a bit more, dig more deeper in understanding if the information that it provides is correct and how to evaluate whether it's actually correct. Because if you read information which is incorrect, if it's hallucinated, then you might have a problem in your hand. So although the idea is interesting, the problem with using LLMs out of the box is that it's going to come up with answers which are, or it's going to come up with notes which do not exist. So I would say that is where you have to start. And in terms of scalability, yeah, once you solve the basic problem of fixing this scenario, then you can think about scalability. Scalability, where you can then think about a messaging system where there is a message queue. If you have several people asking for the same some answers, then you can cache this information. Then you can then think of a caching system. You need to think about different systems. I'm not sure if you're in the computer science or software engineering sort of like a
Yeah,
background. Yeah. Then you can think about all of this. So you need to think about how do you scale this up, how do you make it useful for so many people. But then yeah, overall the idea is good. The problem I would say is that you need to do a lot more checks given that
I
LLMs hallucinate a lot.
I checked that output, which is pretty good. Basically, I extract topics from course outline and generate one by one with using different models. Like I
Yes.
use uh,
Mhm. So
with
yeah, I can understand what you're saying. If
yes,
you think this is good, and if you say if the results are reasonable, then this is actually quite a nice approach. Try to share it with more people. Just make sure that everyone who uses it also has a textbook to check with. Because the problem is that, like I said, so it might come up with something which does not exist, which might be dangerous, especially if you go to your exam and then write something that an LLM generated, then your professor might not be happy with the answer. So this is why I would suggest, although the idea is good, to make sure that there is some sort of at least books or knowledge below which it refer if it refers, if it cites this to the information that it generates, then that would be a wonderful idea.
so what do you think that project are the part of generative AI?
It is okay, of course it is a generative AI idea. So basically, because you are giving it an outline and then you are asking it to come up with sort of like course notes, which is exactly what a generation task is, right? So basically, you are giving it set of notes, set of points, and then you're making the model come up with the answer. So I would suggest yes, this is still a valid idea.
Thank you.
Mhm. Okay. I see also two more people raise their hands. Just bear in mind that there are only 5 minutes left, so please make it quick.
Hi, Karthik.
Yes.
Hope you're doing well.
Hmm.
Uh, I come from a computer vision background,
Hmm.
and I was thinking about using this capability. This was something pretty new to me
Hmm.
in my computer vision task. So I could make computer vision tools, and then an agent can decide which tool to use. Uh,
Yes.
but as I was thinking about the robustness of the overall program, I was thinking that computer vision expects very intricate and very to the point inputs for
Yes.
it to be able to run. And
Yes.
as far as my limited information is, LLMs are they don't give you the same answer even if you ask the same question twice.
Yes.
And how do you what's the uh, technique that you do for robustness so that if let's say it is calling a tool for object detection and it
Hmm.
has to give a certain number of classes and certain number of input every time
Yeah. So this,
and
yeah, I can understand your
so
question. So with the
that's
computer
the
vision,
problem.
with the computer vision sort of scenario, you need to then move all the questions based on the tools. So then you ask a question. Your question would probably be a bit more like an interaction with a language based model. But then you all your answers would be based on, for instance, like tools that you provide to the agent. And in that sense, you can completely avoid the LLM to make its own answer. But you will be calling, for instance, a method which exists. For instance, if you're running, I don't know, a feature matching, or if you're trying to do some more object, not object detection or generation, but more like, I don't know, the actual method itself, you can actually make the call that particular tool, but you can define all of the description of what exactly each of these methods are, what each of these are doing before you can ask the tool to actually call them. So in that sense, you can then integrate the computer vision part. I can actually create another example where you can actually do such things, but it's you do it through the tools. So you make the agent actually call an external or the tool, and then make sure that the LLM does not do anything as such, but besides than just by basically interacting with the user. But then it calls the tool behind the algorithm that you want to execute, and you do not let the LLM do anything besides just interacting with the user.
Thank you.
Does that make
Thank you.
sense? Yeah. Okay. Any other questions?
Yeah, hi, Karthik. So
Yes.
I have just a simple question from you. From where I can learn agents? What is a good starting point, and can you provide me the best robots and good
Mhm. You can,
resources so
yeah,
that I can
given that
start
there
and
are only
plot
two
it?
minutes, you can go to deeplearning.ai. So deeplearning.ai has very nice resources, very short courses on agents, especially, and then you can start there. The best way to also learn about these agents is to build one yourself. So start to have some examples like the course, the notes generation. So things like that. If you have some problem that you have day to day, try to build an agent for that. But besides that, that's the best way to learn. You will also have a problem that you want to solve, and then go to deeplearning.ai to find short courses that you can finish in, I think, 2 hours, 3 hours. You get very good knowledge there, and then you can think about specializations if you like the course, and then if you want to develop further.
Thank you, Karthik.
Sure. All right. I think we're pretty much at the end, and I think the call might end in any time now. But yeah, I think if you have any further questions, ping me, and then we can talk later. But have a good day.
Thank you, Karthik, for your time. And I will share Karthik's link on the WhatsApp channel as well. So hope you guys learned a lot. So thank you very much, everyone, for joining, and have a good day.
All
Thank
right.
you, Karthik.